Welcome back, and in this video we're continuing moving forward with deploying SSL certificates within our project. In the earlier video we went through the steps of creating the configuration or installing the ACME client and going through the configuration and requesting a certificate from Let's Encrypt. And I wanted to review that with you because after I did the video I thought perhaps that I never did stop and actually explain how that works. So we draw the internet here. And over here we'll draw our pf1 or pfSense box. Out here on the internet we have two players. We have the Let's Encrypt certificate authority, they're a CA, and then over here we have our Azure DNS. And this part here is flexible. It could be any DNS that's internet accessible. It doesn't have to be Azure. So here's what happened. We installed they call it a cert bot, but it's the ACME client onto our pf1 box. So we went to packages, found ACME, installed it, and when we did that, then we got a client. We got a back end to make requests for certificates, and so we filled out the forms, we gave it our information, and then we went to issue and renew. And here's what happened. After we filled everything out, a request was sent from pf1 out to the internet to Let's Encrypt with our information. Let's Encrypt responded with saying, okay, if you're really who you say you are, then I want you to populate these strings. Remember, they're very long. I'm not going to try to write them out, but they were very, very long alphanumeric strings. Okay, so that's what we got. That information came back from Let's Encrypt. Let's Encrypt said, well, let me try to put some EA15, they were very long strings. What we then did is we said, okay, we'll do that. So we went out to our Azure and to our domain, and we created a TXT record, and we took those values, the two values that Let's Encrypt gave us, and we populated a TXT record in our domain with those values. And that is the proof of ownership, is that it's because we had the ability to modify DNS records for our domain that constitutes enough authority to also request certificates for that domain. So that was the key thing, and I didn't feel like I really kind of helped you see that. So we did that. So Let's Encrypt reported back. Remember that green screen we got and it had all that text in it, but in there we found those too long strings, and it said make a particular record type. We went to Azure DNS, we created that record type, text record, we populated those values, and then over here what we did then is we went ahead and we said, okay, let's go for it. So we gave it the green light. When we gave it the green light, that was then sent to Let's Encrypt, who said, and what we're doing is saying we're good to go. Let's Encrypt then went out to the internet. It didn't actually know to go to our Azure DNS server right away. It went to do a lookup. In my case, it went to do a lookup for ak.bobstaco.com, and it went through top level domains. It went through everything that we normally do for DNS, and it wound up then over looking at our DNS server on Azure and found those records, and it verified. It said, okay, I asked them to put this text information in, and there it is. And so then Let's Encrypt says, I'm satisfied, and then it responds by generating the certificate and sending it back to us. It's a very cool process, and it's only been around for the last couple or 3 years. And the thing that's really great about it is that we can get these certificates for free, where we used to spend a lot of money getting certificates, like a lot of money. They were good for longer. Certificates, we used to get them for 3 years, even 5 years, and now just because the nature of our industry, you can't get a certificate for more than 12 months. And so getting one for 90 days isn't really that big of a deal compared to 12 months. I mean, it's shorter than 12 months, but it's also free. Once we have then that certificate, we were over here then to pfSense, and we went into the cert manager. And you got to be careful here. The landing page is the certificate authorities, but the certificates themselves are right here. And we found our cert, and we said super cool. We then bound it to the web configurator. I know this is all review. But then where we're going to pick up here is we exported the certificate, the key, and the package. I believe it's called a P12 package. And then those are in the downloads directory on this machine. So see if I'm in my downloads directory. I'm on the Windows 10 machine, and the Windows 10 machine is currently on DevNet. And so there are those values. There's not values, files. There are those files that we exported out of PF1. And what we're going to then do is we're going to use those, because it's a wildcard cert. We can use it on rtr.ak.bobstaco.com. We can use it on www. We can use it on anything that ends in .ak.bobstaco.com, and that is the limit of the wildcard cert. It's just anything, any host that has as its domain name, or the domain portion of its name, ak.bobstaco.com. So let's look at how we do that. There's actually a couple different options. So this is PF1. Let's go over now to RTR. And again, just I want to be sure you understand which firewall we're on now. This is RTR, and RTR is actually not a firewall. It's just a router. We disabled the firewall feature. And if we go over to System Cert Manager, go over to Certificates, we have the built-in web configurator one, which we know gives us this error message. If you try to go to it by name, it's a self-signed certificate, and so it's not recognized by anybody. But what we can do here is we can go to add or sign, and this is where I guess you'd say that the critical steps come in. So please let me show this to you. We go to on the method menu here, we hit the drop down and we say import an existing certificate. Okay. When we do that now, it's giving us two options. We can do an X.509 option, or we can do a PKCS or PFX package. Either one, we're good to go for either one, but let me show you both. For the X.509, we can actually copy and paste. In fact, notice it says that here. Paste this X.509 certificate here, and then you paste the key here. So what you could do is you can come over here and we can examine this certificate. So again, I'm on my wildcard cert that I got from Let's Encrypt, and I go to the pencil here to edit it, and you can copy and paste these values in. You can do that, and that's pretty easy. You can do that in this case. In other cases, we'll have to do different methods, but in this case you can. So we could do Control-C copy. We could then come over here and we could do Control-V paste, and you could do the same thing for the key. We could also then go ahead and hit this choice, give it a name, like like wildcard.ak.bobstaco.com, and then we would browse on the file. So I go to my downloads folder, and it's the one that says personal information on. It's this one. We would click on this, and then we would go ahead and save it. Now, when we exported it, we did not assign a password to it, and in other operating systems you will. It'll prompt you for that, but we didn't do that. Windows will do that. It'll when you go to export a certificate, it'll say, hey, it would be a good idea to go ahead and assign a password to it. I like to also check this box here, which says if there are any intermediary certificates, and there often are, to go ahead and import those as well. So I'll let you do it however you choose, but then the end result, and I'll do it, I guess I'll pick one of these ways and do it, but then before we quit this video, we'll come back and just verify that we did get this to work correctly, and if not, we'll troubleshoot like we did in an earlier video. So I'll pick up with you just in a minute. Okay, I'm back, and everything went good on that one. You remember last time we did troubleshoot, but everything went good on that one. I didn't have to reboot anything. All I had to do was I imported the certificate. We were just there, Cert Manager certificate. I went ahead and imported the P12 package, and it gave me everything I needed. I named it. I gave it that. I did that, and then I went over to Advanced, and I switched the web configurator from the self-signed certificate, the default, to the certificate I gave it. I then went in and opened a new tab and went to rtr.ak.bobstaco.com, and it logged me out of my other tab and then brought me into this tab, and everybody's happy. You can see here that the certificate is fine. Now there is one thing here that we've assumed, and that's that these names rtr.ak.bobstaco.com and pf1.ak.bobstaco.com, that you have DNS set up to support those names, and we should mention that, right? As I'm working with you and we're troubleshooting together, and as I'm grading the projects as they're coming in, I was just reminded of that. I was reminded when I was grading, I saw that the DNS wasn't quite right. And the way that we would check that then, first of all, let me just show you that I'm on DevNet. You can see here, and if I was to do an ipconfig/all, you would see that I am using my DHCP lease, DHCP server shown here. Okay, so I'm over on DevNet, but really what I want to show you is I want to show you that DNS works. So DNS is required for these certificates to work. The certificates are tied to a name, not to an IP address. Now you can create certificates tied to an IP address, but it's more common, far more common, to have them tied to a name. Bob and I were having this discussion, and he was talking about how that he's made a habit of including the IP along with the name, and I thought, hey, that's pretty cool. That's pretty cool. That so you can do both. And this one certificate actually has two names in it. It has, for me, it has ak.bobstaco.com, then it has a wildcard .ak.bobstaco.com. So what's really important here is that these names are resolvable. So you can't open a web browser and go to rtr.ak.bobstaco.com if that name can't be turned into an IP address. And so you have to have DNS functional. And what I'm doing here is we're testing it. And so I went to NSLookup. This is our go-to tool for DNS, and I just said RTR. Now I could have also put in rtr.ak.bobstaco.com, okay, because that's what I put in the web browser. And you can see that it resolved it. In fact, it knows about all four of its IP addresses. It's got one interface on CorpNet, one interface on DevNet, and it knows about them all. So this DNS is set up correctly. And then the same thing for PF1. So if you install your certificate and you're not able to get the website to answer, then the next thing to look at in troubleshooting is to look at that when you type into your web browser that the rtr.yourdomain or pf1.yourdomain, that what you're typing in is actually able to be converted into an IP address through DNS. And if it's not, then the certificate won't even be called. Nothing will happen until you get that set up, so that when you type the name in the web browser, DNS gives the IP, the web browser then goes to the IP, it presents the name matches the certificate, and everybody smiles, and you get the lock symbol here. Okay, so we have one more certificate to work with, and that's over on server 1, but we'll do that in a separate video. I hope that you're finding this helpful and interesting, and I'll see you in the next video.